Hi guys, welcome to Things Tech. In today's problem, basically today's video will focus on the one of the basic concept, I would say, dynamic programming, which like getting asked in multiple interviews, right? It's you'll see nowadays it's a common. So most of the companies ask these questions, good companies I would say. Okay. So for today's video, right? So we'll try to focus on the basic concepts of the dynamic, how you'll think and how you'll implement. So whatever you're thinking, how you can translate that to the implementation. That is our main motive for today's video, and mainly focus on not too much complex, only 1D, so one dimension dynamic DP we'll focus on. Okay, let's jump on the problem without wasting a further time, right? So for today's, right, so the first problem that I'm showing you, right, basic, starting from the basics, climbing stairs. I think this you have solved in your college days, or you should think about the dynamic programming and how we'll try to work on the problem for these whenever these sort of problem comes, right? So that is a thing. So in this, I would say, just if you see, right, the problem which is mentioned here, right, each time you can either jump a 1 or 2 step and count the distinct paths, right? So just what it says is, just you are given a n, which is the stairs, right? Let's say fourth stair you have to reach. So what is the path? So let's say fourth you wanna reach, you can reach via 2 or 3, because this is n minus 2, n minus 1, n minus 2, or this is n here, right? Now 3 you can reach it via 2 or 1. Similar 2 you can reach it 1 and 0, right? And 2 again 1 0 and 1 0 and 0, right? And 1 0. So these, so if you see, this is a one path, this can be another, this can be another, this can be another, this can be another. So that's how you get the, you have to count the total paths, right? So I'll just show you how you write what you are thinking, like you have to reach from n minus 1, n minus 2, how you translate this to the pseudocode, right? So let's say we have to count the steps given an n, right? If n 0, right, from the 0 it will always take you 0 step, right? So you have to return 0, and then you have to count a step n minus 1 plus count n minus 2, right? This, right, this you have to do the sum again, you have to call the same function, right? But if n equals to 1 comes, right, it will always be the 1, you have to return 1. If n equals to 2 comes, then you have to return 2. These are the base condition I'm writing, because okay, 2 is not required, I think. Yeah, 2 is no longer needed, so 2 we can remove. 2 will automatically enter. I'm just considering base, because when you do n minus 1, n minus 2 on the 1, so it will become negative, so I don't want that to go negative, hence I've just written a base case for 0 and 1, right? So this is basically 0 for here, and here it's 1, right? That's how you count it. So this way it's like a, if you know the recursion, right? So simple pseudocode which is using a recursion like a stack, where it counts, like it has to, let's say, get the result for, I would say, fourth, it will push fourth, then it has to come 3 and 2, both will come here, right? And then 2 will have 1, and 1 and 0 always has the result, so 1 and 0 will be like total 1, right? Correct, because 0 you will start anyway. So from the 1 already has the result, so it will not go in the stack, because it already, you have the result for the 1 and 0. So for the 2 it will total become like, how many paths are there? 2 paths are there, from 0 or 1 both you can reach, right? And similar for 3, you can reach it via whatever is coming from 2 and whatever is coming from 1, right? So which will become 3. So then 3 will come from the 2 and 3, then you will just sum it up, right? That's how it goes, because these are the different paths, so then it will become 5. Similar way you can write the code, right? But how you can do it, so this is the way you can do it, right? But this is like a recursion. An iteration similar, you can take an array of dp of n, and just you can write a 0th index as a 0 and 1th index as a 1, and just your simple, whatever you have written in recursion, right? So for nth, you have to dp of n minus 1 and dp of n minus 2, right? This you have to write, and n may you have to store, and then you can return the at the end dp of n. That's how your answer will be. Let's move to the next problem without wasting further time, right? So this is like the problem is house rover. Okay, so what it says is, okay, yeah, so basically you are professional rover to rob houses along the street. So each house has a certain amount of money. So these are the money 1 2 3 1, right? So when the police won't come, when it will be automatically okay. So the constraint is key, basically each house has a certain amount of money. Only constraint is stopping of you from robbing is adjacent houses have the security system connected. It will not automatically contact the police if two adjacent houses are broken into the same on the same night. Okay, so you can't rob adjacent ones. That is your whole point, right? So it's again a simple problem, expanding this, right? So the problem is house robbing, right? So what is trying to say, just let's take the case of 1 2 3 1, right? So you have a 1 2 3 1, these are the house IDs, like a 0 1 2 3, and we have to give the, basically the goal is maximum amount of money you can rob, right? So basically for finding the maximum, right, what I try to say is either you can rob, this is the ID, right? House ID, I would say. Okay, either you can rob a house ID 0, okay, or a 1. Okay, if this is a problem, right, if you have a house ID 0, then you can rob the ID of 2. If you are at a 1, then you can rob the ID of 3. If you are at 2, then no further thing is remaining, right? So this is the way you can rob. There can be another, if you rob the 0, then you can directly rob also 3 also, right? Not adjacent, but that is possible. If you have robbed the 1, then directly you can rob 3 also, or 2 you can't rob, right? So you have to make sure, basically for robbing the I, either I minus 1 or I plus 1, right? These are the two adjacent. Those should not be robbed, otherwise police will come, right? That's a whole goal. So let's try to think how we'll gonna implement. So our goal is to maximize the profit, right? So what you do in such cases is, so basically let's say start with the, you have an array of n, right? 1D, like n size. We should know at every index what is the maximum profit I can make, right? Via any combination, right? How you can store those combination is simple. So let's say, if I would say key, basically you are at a 2, so 2 you can reach it via either I minus 1, like this is I minus 2, because I minus 1 not possible, or further below that, right? Or I would say in simple terms, if I is there, whatever is the maximum at a I minus 1, either I can take that, or whatever is the at a I minus 2 plus whatever is the money at a dB of I, money of ith index, right? So what I'm trying to say is, whatever you have computed till I minus 1, or whatever you have computed till I minus 2, if you have computed till I minus 2, whatever the money, plus then only you can sum the current index money, else you won't. Else either you can pick this I minus 2 plus current index money, or a I minus 1's money, and take a maximum. That way you can store the ith index money, right? So I'll show you how I have written the code for this. This is very simple, straightforward. So basically base case, I minus 2, I minus 1, that's what I said, right? So I minus 1 is the basically, if both are just checking index safety, right? It's not going negative. If I minus 2 is there, right? Previous 1 and previous 2. Just checking the index safety, and then what I'm saying is previous 1 you are picking, then you can pick only that. Else previous 2 you are picking, then you can take the current money also, and then find the maximum, because these are the only two ways you can come to the, like you can find the maximum at a current ith index. And whatever, once you go through this loop, and whatever is at n minus 1, that will be the answer, right? So that in that case, if you are taking a dp of, if you are going via 0 1, that n minus 1, or and whatever way you create array of db. That will be your answer. This is a simple question, right? Let's jump to the next question again. So word break question, this is interesting. So basically what it says is, I'll just show you. So you have the LeetCode, okay, and the another is the this is the word, S word, and another dict you have leet and code. So what it try to say is, you have to find a word. You have to find first if the word break is possible in such a way you can break the word from anywhere, but it should exist in the dictionary, and this whole word should exist. So it should not be like you match the sleet and other thing you didn't match. This whole string should be broken in such a way that whatever the string you are creating, like from the LeetCode you are creating leet or code, both words should exist in the dictionary, right? This is a dict. That's what mentioned in the question. There can be another ways, lee and t code, but this doesn't exist. So we have to find a way, if it is possible to break a word in such a way such that the dict, all the words that we are breaking into are lying in the dict, right? That's the whole point of it, right? Yeah. So let's try to jump on the, like how you'll think, right? So let's say another example, there can be duplicate also, that is fine, like apple code, let's say, an apple. This is the dict. This is like a word, your word, sorry, S, and dict is apple and code. In that case, this is dict, right? Apple is already part of, code is already there. Duplicate is fine in the word, not dict is always having a unique word, okay? That is the one of the case it was mentioned, hence I just covered that also here. Now let's think how you'll implement. Let's say we have the S. Let's jump to the LeetCode, right? And we have the dict as a leet and code. How will think ki basically we should break this, right? What can be the possible ways to break, right? That is how we think. Just think like a start from the basic. What you do in the basic thinking, if you go right, you'll try to build the word, right? So just try to think in a basic way, so at least we will be able to come up with a brute force approach, right? So let's say I'm building the string, right? So I'm just iterating from the 0th index. So I see leet is there, right? So if I'm going from the 0th index, right, so what can be the possible ways, right? So either I pick L or I don't. That is not an option because I have to use the complete string. So if the one option is I pick the L, another option is find if the L is part of my dict or not. If L is not part, then I have to continue build leet till leet I come, right? Now till leet if I come, right, now I have two ways, right? Part of a dict, then the current word will become empty because the leet is already exist, so I will split it, right? Another way is I continue with the leet and I just append C. I'm going further, okay? So these are the two ways. So when the two ways will come, when there is a word which exists in the dict, and other option can be I want to continue, right, without splitting, right? Because there might be other cases also, right, where cases like leet C and code, right, and leet. If let's say this comes and if I split it here, the leet exists, but let's say another word is also there, leet C, then you will miss those cases. Hence we have to cover all the like I would say options, right? So that's why if you go this way and just keep repeating this till you reach the basically end of the string, right? And if end of the string becomes true, then just propagate that to the bottom up way, right? So that's how you implement this, but this will be like there can be many possible combinations, right? So it's going exponential. Why exponential? Because you are splitting a word, and then splitting of the word also is like can happen at every index also, right? If let's say the cases like B, C is already part of that, you start creating lot of branches in the your basically recursion. So that will that is like a complete exponential, and it will be not, I would say, good approach. It's a brute force, right? So let's come to the approach of the dynamic programming, DP approach of the word break. How you break, right? Right. So our problem still continues. LeetCode is a string. We'll just focus on this only. Leet. So you understood brute force approach now. Like how we can optimize this to our DP, right? So think about it like in a way you have a string, right? Let's say the basic thing you have to iterate. This is I think hope you will not have any question on this. You have to iterate at every index for lead, right? Once you iterate, you start building the word, but at the same time you have to find, right, whether it exists or not, right? So what can be the other way of thinking is, let's say this size is n. So we should know till what point of time the word exists. So let's say think you have a DP of n size, right? For this lead code, right? So this you have a DP. So by default this is false, let's say, because no word exists. I don't know. Now I need to construct the word, right? So I start constructing from here. Lee, not possible, not possible. Here I found the word. So this becomes true. This is one of the point where I found the word. So this is the, here I can split. This is one of the way. If I split, then from here again I go, right? Like C. From the C if I go, right? C is there, O is there, but there is no word exists. So this will remain false. But this also exists. So this will become true. So if you see, right, this is true. If I just, this is, let's say, ith index minus size of this word, right? Size of this word is, let's say, some k, I minus k will reach me this index because I'm just going backwards, right? So again, this is true. This will reach me till 0. So this way, I am just found, like from here I reach this because this I'm able to, and then from here I reach this. That means these are one of the break of the word possible, right? Where whatever the word I'm breaking into, it's part of in the dict. So this way you can do it. How you'll implement this? Let's jump to the implementation part. So this is very straightforward also. This one also I'm just showing you how you can. So let's say you have a n length string. 0th I'm just taking n plus 1 so that I know from the 1 to n1, and the 0th I'll take it true. Okay, so that I can fill it by, like, I should know the default one, right? Now what I'm doing is for every index, right, I'm just getting into the size of the word, right, which I have to match. So I have the k words, let's say. For each word I'm just going from the ith to minus that length and seeing if that word if that size of the word is possible or not. If it is possible, right, and before that, right, starting point, till that I'm able to break the I'm able to build the other words, right? I just don't want building a words which is half of the word exists, half doesn't exist. I want to construct a full. So that's why this condition of UCDP of ST, right? Starting point should be like a possible word break, and other half I'm building it, right? So here what I'm doing is whatever the starting point with the word dict size, right, of the current word that I'm trying to match, just extracting a substring of that size, right, and just matching it. If it is the same, then that index becomes a true. Which index becomes a true? The current one, from where I am breaking it, right? The start I know, the current is a I. Till what point I'm breaking it, right? So that way I'm just marking these words. So, and then at the end it is a whatever is the exist in the nth one, right? So this way I'm starting from here. From here I reach true, and then I'm went to true. If this becomes true, then I'm done. Okay, so if it is a true, then it is possible, else it's not possible. Yeah. Now let's jump to another problem. I think we have covered most of them. Coin change is similar. I'm just should I show you? Okay, let's try to see coin change also, right? These are similar, but yeah, it's pretty straightforward. So what it says is coin change. You have the let's say array 1 2 5, and sum you have to build is 11. Okay, what it try to say is you have to do it in the fewest number of the coins you have to use. Okay, so you have to use the fewest number of the coins to build the sum. Simple question similar to the previous one. In the previous one, if you see, right, what we try to solve it is breaking the word in a such a way such that the dict exists. Now dict is your coin and the word is your sum. Replace it. It's the same question. Okay, so basically if you see 11 is a sum, so what you do is you try to start from 1 to 11. What are the possible ways to build, right? Correct. If you're able to build the 1 as a sum, 2 as a sum, 3 as a sum, whether it is possible or not, and at the same time you're minimizing the coins, right? That is the whole point. So let's say if I want to build 11, this will take 11, right, coins. This is possible. 5 only, I'm just saying 5 this, and then you have to use this. So 5 and 6, this you do 2 plus 1, so 3 is the answer. This is what is mentioned in the question, right? Now how you build it, right? So that's what I said, right? You have to try to find the possible ways for each. I'm just going into a DP problem, not going in the brute force approach where you do the recursion and just going in the exponential complexities. Okay, as earlier I mentioned that a similar approach can be applied here also. Okay, so just in the DP problem, right, DP way, how we solve it, 11 is there, so 11 is possible from multiple ways, right? What are the multiple ways? So let's say I start with a 0, right? So 0 1 is possible. If I want a one sum, how is possible? Only one coin, right? Let's say 2 is possible from the 1 coin also or 2 coin also. Which is the minimum? This 2 1, so this will take a 1. Similar you have to do till 11, right? For each you have to find the similar way. How you find it? So similar, loop it to 3, loop till amount, and then what you do is try to find the starting point. What is the starting point? From the current minus the coins of whatever the coins that you want to use, and see if that start point is the possible to reach or not. If it is possible, then the current index you can reach it, right? And then just do the minimum, right? If you're doing a first time, just assignment, and if it is not, then you do the minimum of I or st plus 1 from where you are coming, right? That's whole point, right? Yeah, I think last question we'll do is on the DP. 1D DP is the longest increasing subsequence. This is a standard problem, right? So longest increasing subsequence. So in this, what it try to say is basically you have the string, right? And now what you have to find is 0 1 0 3 2 3. Find the longest increasing subsequence. For finding a longest substring sequence, right? So we have to find a maximum length subsequence. So it's not a contiguous element, it's the element with the you can pick a random, like a 0 I can pick, then 1 I can pick, it's increasing, 3 I can pick, but again further I will not be able to pick. So if I pick 2 then 3, so this is a 4 length. So this way you can pick, this is a 4 length subsequence. How you'll try to find via DP? There can be other ways, just I'll focus on DP for this video. Okay, so in this what you do is, if you can try to find because you need to find a I would say maximum length, right? So what you do is, for the maximum length you have a, let's say, n length array. If it is possible to build 1 to n, then you'll be able to find a maximum length. What I mean to say is, if you can find a 1 length substring, 2 length subsequence, not substring, sorry, subsequence, then 3 length, if you are able to find, then you'll be able to find the basically till n length, right? And whatever is you are able to reach via maximum, right? So basically maximum length, that is your answer, right? That is the whole point, right? So what you do is, for every length by default 1 will always be true, because the 1 element is always be the increasing subsequence. Then for the 2 you start building. So let's say For the 2, what you do is you try to see the elements, right? For the 2 is whatever you are starting with, you try to see if the current with the previous elements, if this element is increasing, then this can be the element which can have the 2 length, right? And just try to do the maximization, right? Simple jumping into the code. Okay, it's a very easy problem, right? So just you initialize with the n with the 1 because 1 is a by default. Okay, and what I said is you already done with the 1 length, you're starting with the 2 length, right? And just my index is starting from the 0, hence 1 to n I run, and then 0 to I is a basically because that is a length you are trying to build up with, right? So like for 2 length, 3 length, 4 length, that's how you are doing it, right? So 0 to I you are trying to search. What you are saying is whatever is the ith with the I'm comparing with the j, right? And j when I'm comparing, right? So basically I'm trying to see if it is increasing, then that length I can increment without, because till j I'll be able to build, right? Because I is there, and whatever till j is the answer, I just need to do the +1 because from the I I'm picking the j, right? That's the whole point, right? And at the end you have to do the maximization, right? That's all. And if you see, this is the whole expression you need to find. This is a main expression. So why I'm doing, because I need to find the maximum length subsequence, right? In short, hope you understood this. Okay, so now let's jump on to the further. Okay, yeah, I think this covers the whole thing. And just answer, I'm storing it in the variable so that, because there can be possible like I can have the string length of not a string, I can have the array length of 1k, but subsequence length maximum is coming 12. So the 12th index might have the answer, but I need to I just store the maximum length in the variable so that I can just return instead of searching in the array. Otherwise I have to find the maximum in this array. Okay, cool. Then I think, yeah, that's all about all I want to cover in this video. And for the upcoming video I will focus on 2DDP, that is next video. Okay, thanks for the time, and like, subscribe and share the video. Thank you.